Hello, welcome to my production project product presentation. This video would demonstrate a research testbed environment that is used to evaluate how different routing strategies perform in deciding whether to process computational tasks on local edge devices or remote cloud servers. The testbed consists of four main components: Sumo simulation to generate tasks based on vehicular data, the routing strategy implementations that route the tasks, and the Raspberry Pi and cloud virtual machine that act as the edge and cloud nodes to receive and then process the tasks. It is best to view this as a data pipeline where each component intersects to manipulate the flow of data. The system collects performance metrics to compare how well each routing strategy functions. This is the Sumo simulation setup. Here on the left hand side we have the Sumo configuration file, which dictates the output of the simulation and the type of data it has to give us. It also gives us the speed and the length of the simulation and the length of how long the routing strategy is going to be tested for. On the right hand side you can see the actual traffic model, which is when it's run and initialized it will generate the vehicular data based on the traffic model, and it will give us things like vehicle positions, speeds, spatial context in terms of the traffic, which we can then be used to turn into varied tasks that the routing strategies could then make their decisions on and give them enough variation to fully and rigorously test them. Next we have the edge node setup. Here you can see the physical Raspberry Pi that serves as the product's edge computing node. When initialized, it hosts its own flash server that receives the tasks from the router and then processes the tasks. It's integrated with the server metrics file. It integrates to process the tasks and then collect the system performance metric. Next we have the cloud node setup. This is set up as an AWS EC2 virtual machine, and it runs exactly the same to the Raspberry Pi edge node. It has its own flash server that is set up to receive the tasks from the router when ready, and it will process the tasks as well, integrated with a symmetrical server metrics Python file. To record the metrics, this similarity ensures a fair test for the routing strategies. We have the initializing of the system and chosen routing strategy, which is the context. To begin, we need to initialize the edge and the cloud server. We have SSH into the edge Raspberry Pi to do it remotely. We then start the real-time pipeline with the context-aware router for the demonstration. This brings up the Sumo simulation, which needs to be ran just for this demonstration, otherwise it'd be automated like everything else with the real-time pipeline. It extracts the data from each time step to create computational tasks. The selected router will route the task accordingly. The logging will reflect that. You can see it functioning and each server receiving their tasks and the router distributing them. Here we have the system and strategy in mid-process. The context aware is still running and it's recording each task context score and where it has been processed, so you can see whether it's been sent to the edge or whether it's been sent to the cloud. You can see whether it's met the deadline or it hasn't. You can also see the location, distance, the task urgency based on the deadline, and the computational complexity of each task. And you can see how they've been distributed, and the Sumo simulation running on the right hand side, and it incrementally in real time distributing the tasks. Here we have the ending of the system process and the gathering of metrics. When the simulation has ended or the router has been stopped, the metrics can be tracked using the router tracker file, which is automatically generated when it is stopped. For testing, routers are run for 30 minutes precisely for each router to ensure that the results are fair and well aggregated. Here we have the results. As you can see, you see the total tasks, how they've been distributed, the end-to-end latency, the average processing time, CPU usage, which is talked about in the report, and the deadline satisfaction, which is a key metric for consideration. Today's demonstration was of the context-aware router functioning. The deadline router is utilised in the exact same way when initialised with real-time pipeline.py. The deadline router will need to be specified. Then that will run for the 30 minutes, just like the context router. It will distribute the task based on the characteristic of the deadline. The clue is in the name. It will run for the 30 minutes for a fair test. It will produce a similar performance metrics file. We can then use these two files to compare both routing strategies and then analyze from there. Thank you for watching my demonstration, and I thoroughly hope you enjoyed.